This is an example for partial derivatives. Given f of xy equals x to the third minus 6x squared y plus 2y squared minus 14, find f sub x, that is the partial derivative with respect to x, and f sub y, that is the partial derivative with respect to y. Then find f sub x of 1, negative 2, and f sub y of 3, 0. So let's start with f sub x. So the partial derivative with respect to x. And when we find this derivative, we treat y as a constant variable and x as our variable. So the derivative of x to the third would be 3x squared. The derivative of negative 6x squared y would be negative 12x. And then we're treating y as a constant, so times y. And then the term 2y squared, since we're treating y as a constant, is 0. And the derivative of negative 14 is also 0 because that is a constant. That's our partial derivative with respect to x. So now for our partial derivative with respect to y, f sub y of xy. Now we treat y as our variable and x as a constant. So this first term, x to the third, is a constant. Derivative of a constant is 0. This middle term, the derivative would be negative 6x squared, because the derivative of y is 1. This third term, derivative of 2y squared, is 4y. And then negative 14 is a constant. So these are our two partial derivatives. And now we'll plug in these 2 points. So f sub x of 1, negative 2 gives 3 times 1 squared minus 12 times 1 times negative 2, which is 3 minus 12 times 1 times negative 2 is negative 24. So 3 plus 24 gives us an output of 27. And then the other partial derivative, evaluated at 3, 0, gives negative 6 times 3 squared plus 4 times 0, which is negative 6 times 9 plus 0, which is negative 54.